Hello, and thank you for joining us for our supercomputing series of webinars. Today we're joined by IBM. My name is Maz Lopez and I'm Head of Marketing for Boston. Before we get into the topic of today's webinars, I just wanted to let you know that we're also going to be undertaking a Q&A at the end of this session. So if you have something that you would like to ask our presenters, please click on the question mark icon in the top of the Teams app and type it in. Time permitting, we'll answer as many of these as possible, and you can type at any point and submit your questions at any point during our webinar. The topic of today's webinar is Building Better Products Faster with the newly launched IBM Bayesian Optimization Accelerator. Our presenters today are Glen Rosenberg, Director of Cloud and Managed Services at Boston Group, and Martina Naughton, Worldwide Sales Leader for HPC and AI at IBM. Over to you, Glen.
Hi, my name is Glen Rosenberg and I'm Director of Cloud and Managed Services for the Boston Group. I have a very brief agenda today for this part of the talk, with an introduction to Boston, a standout innovation, and then an introduction to the IBM part of the talk. The Boston Group has a proud history in bringing innovation to market and has built up a reputation for both understanding the products that it sells and delivering high quality support and engineering services to ensure that our customers maximize the benefit of the innovation. Mirroring that, I've been working in IT for over 30 years, from the first PC through mainframe, mid-range and esoteric compute, and then back again to x86 technology powering many of today's supercomputers. Part of my role as a technologist supporting customer projects is bringing knowledge of technology trends, imminent technology changes, and supporting the selection of best solution, whether that is application specific or for more generic workloads. But the underlying goal is always to drive value, whatever the customer determines that value to be. Last year at Supercomputing in Colorado, amongst all of the hardware announcements and advances, IBM gave presentations on their Bayesian optimization tool developed in their lab. It caught my attention as a number of the projects I was involved included CFD, computational fluid dynamics, or other computationally heavy workloads such as machine learning and artificial intelligence. The ability to bring what was heavily focused in the knowledge of data scientists at the IBM labs, packed to enable anyone to aim for the best single prediction through optimized tuning parameters, was very exciting, and the results were very compelling. I wanted to understand how Bayesian optimization worked, from the ability to exploit unexplored regions, near performing configurations, to its uses in machine learning, and why that would benefit CFD users to this level. With the advance of modern machine learning algorithms and the vast number of hyperparameters, using Bayesian optimization, you can significantly bring down the time spent to get the optimal set of parameters, and therefore reduce the cost and the time to produce the result. I saw this running on power technology, but one of the issues is most of my customers use x86, and most have infrastructures that are less than 2 years old. So what would integration look like for them? And what applications are best suited? And most don't have data scientists, so how would we validate the improvements? At this point, it gives me great pleasure to pass the baton on to Martina Naughton, who is the Global Sales Leader for HPI and AI Cognitive Systems, to carry on the story. Over to you, Martina.
Thank you, Glen. Thank you very much. Good afternoon, everybody. As Glen just introduced me, I am the Global Commercial Sales Leader for IBM Bayesian Optimization, which I will talk through at a relatively high level at this moment in time. Much of HPC today, and especially commercial HPC. So when we think about commercial HPC, we think about opportunities and design challenges in automotive, aerospace, drug discovery, oil and gas, electronic design. Much of HPC today is consumed by optimization loops. These problems are attempting to find the best set of design variable values subject to some constraints, where best is either a minimum or a maximum value of an objective function. This is essentially a search problem. That's why we have an image of a child playing hide and seek in a park. The funny thing, though, is if we imagine this child playing hide and seek the way we do HPC-driven design, one method would have the child grid the whole park, put a blindfold on, and search grid by grid. Another method would have that child randomly run from point to point in the park in the hope that he or she runs into someone as they try to find them. IBM knows there is a better way. And in fact, children know there is a better way too. They intuitively consider where they're playing the game, who might be playing, where the good hiding spots are, and which hiding spots are closer versus further away. And they use this knowledge to predict a likely place to look, and then update what they learn when they get there. This is fundamentally a Bayesian approach to searching. So what are we announcing? IBM is announcing the release of a new appliance called IBM Bayesian Optimization Accelerator, or IBM BOA for short. IBM BOA helps product and design teams build better products faster by lowering their iteration time to generate a new and better design. This is an appliance for the IBM AC922 and will effectively be sold as one unit. The solution is standalone from your HPC cluster and helps you optimize the parameters that you choose for your simulation in your cluster. So why is this announcement important, and how does this allow clients to do today what they couldn't do before? So IBM is a leader in the HPC space, and our research group has found a way to drastically reduce the number of simulations required to reach a design point. Our competitors cannot deliver on this promise. So how does it work? IBM BOA allows a client to determine, based on the last simulation, what is the next best simulation you should run. So to go into a little bit more detail on this point, IBM BOA automatically builds a model of the objective function using a Gaussian process, and it updates this model after each simulation. IBM BOA then uses the response model and sampling function to calculate the optimal place in the parameter space to run the next data acquisition. IBM BOA does not change how and where you run the individual simulation. However, instead of a person modifying parameters and rerunning or running brute force methods to survey a design space, IBM BOA will communicate with the HPC environment and make those parameter modifications automatically. IBM BOA will attach to your existing HPC environment and give an optimal solution in a shorter time frame. Information leaving your HPC environment is not the output of the simulation, but the value of the objective function or the value of the response, which means the output file is a very small amount of data. The data going from IBM BOA back into the HPC environment is a vector of design variable values. Even if these values are double precision, 64-bit for a very large 5,000 design variable problem, for example, this is still less than 1 megabyte of data transfer. Finally, it's very important to understand that IBM BOA can attach to any cluster, to any supercomputer, and can run any simulation. IBM BOA can run oil and gas reservoir simulations, financial risk trading simulations, life sciences DNA simulations, CFD crash simulations. The IBM BOA appliance can attach to an existing Power, ARM, x86 HPC environment. And finally, the HPC simulation can run anywhere. The HPC simulation can run in the cloud, can run on premise. It can be public, private, or hybrid. All of these options are completely and utterly fine, allowing you to take full advantage of IBM BOA. So how difficult is it to apply IBM BOA to your design flow? So that depends a lot on the simulator or the HPC cluster being used. It depends on the complexity of the constraints and the response function and how to calculate each of these. IBM BOA uses a set of plugins called interface functions, which are available via a publicly accessible GitHub repository and community. These interface functions are application specific, and they essentially carry out 3 tasks. They read output data from the simulator for the purpose of calculating the response. They create input data for execution of the next simulation, and they submit simulation jobs to the workload management system in the HPC cluster. We believe that IBM BOA will bring massive value to our clients. First of all, we believe that IBM BOA will allow clients to build better products faster by identifying the ideal solution at a lower cost. This will improve time to market and will allow clients to gain a competitive advantage. IBM BOA will deliver the optimal solution quicker with scalable methods that attack real-world problems. IBM BOA will support new paradigm shifts by running only the critical simulation and still achieve the optimal result. We will therefore reduce costs by performing fewer simulations per design. IBM BOA will ensure better business outcomes and increase the productivity, improve the effectiveness of your experimental infrastructure, and increase user efficiency without having to add specialized data scientists. So in summary, IBM BOA, we believe, will enable clients to innovate faster, achieve superior results while using fewer resources. So what is different about IBM BOA compared to products that are in the marketplace and compared to open source Bayesian offerings available? So there are a few points on this, few very, very important points. The first one looks at the whole area of model quality. There's not enough knowledge about the problem to build a good model. So within IBM BOA, we have introduced initialization as a characteristic, as a feature of the offering. And it's this initialization feature that allows IBM BOA to bootstrap itself from no priors or evaluate priors and use the best data set. System usage. Typical optimizations are limited to serial data collection. IBM BOA allows parallel data collection, which enables massive scaling and significant dimensional parameters. This is key to addressing real-world problems. Complexity. Typical optimizations do not work in high dimensions. IBM BOA allows for dimensionality, specifically allows for a lossless reduction with thousands of design variables in small design spaces. And after this reduction, IBM BOA is able to project out again, which means that it can support design spaces that are in orders of magnitude larger. Trust. Typical optimizations do not explain their logic to users. IBM BOA gives explainability in real time. IBM's unique power offering allows us to exploit capabilities which are impractical for our competition to replicate. And in addition to that, there are a few more points that we believe are valuable. First of all, we believe that we are the first in the market with this offering. We believe that there is no offering that leverages all of these capabilities. We believe that IBM BOA is easy to adopt and easy to scale. Please remember, when you consider that, IBM BOA does not require any change to your existing HPC environment. We have some very, very strong data points that demonstrate how this solution performs. And those data points reach from 10 to 100x performance improvement, which I will touch on very shortly. And finally, IBM BOA addresses real-world problems that are being faced by commercial clients. We are able to do this as we have invested in this offering very heavily in parallelization and vectorization. So some key data points. There are 4 examples that I would like to touch on here to demonstrate some of the data and the performance that we're seeing from IBM BOA. So the first one is relevant to clients that are involved in the oil and gas industry. So clients are trying to maximize the amount of oil they get out of the well and are trying to do this in the most efficient manner possible. So understanding the best approach to use for pumping CO2 foam and steam is key to maximizing the oil extraction process. Based on work that was carried out in the University of Austin, IBM BOA was coupled with a reservoir simulator called IPARS, with the objective of defining or of understanding how best to inject CO2 and surfactant. Using IBM BOA, the same objective function was achieved, but with a third less simulations. We believe that this will lead to a very, very significant return on investment for a client that is involved in this industry. Second example, IBM BOA was applied to the process of identifying low toxicity malaria drugs. And instead of having to run 20,000 simulations, the result, the objective function was achieved with just using 200 simulations. That represents a 100x reduction in the number of simulations. And therefore, for a client who is involved in areas such as this represents potentially a very, very significant return on investment. We worked with another pharma company and we applied IBM BOA. We were in this particular use case, we were able to reduce the number of simulations by 66%, which is a 3-fold reduction, and increase the result resolution by 10-fold in a molecular dynamics case involving industrial lubricant mixing. The next example is actually an example that we deployed in our own product. So our own signal integrity team deployed IBM BOA to identify jitter in the Power 10 processor. In so doing this, in so carrying out this, we were able to reduce the number of simulations from 5,600 to 45, which represents a 100x improvement. And once again, that from a business point of view has a significant return on investment. And that from a timing to the market and speed to the market is extremely meaningful. And finally, we have, I'm only giving a short list of examples. There are far more, but it's just to give you a flavour of what IBM BOA is capable of doing. The last example is a CFD case, and for the automotive sector, and it was applied to a Formula One wing design challenge. The IBM BOA team found that the design optimization was completed in 24 hours using IBM BOA, as opposed to what normally would have taken 3 weeks. So that, in summary, concludes my overview of IBM BOA, and I am very happy to take any questions, any comments, any feedback. Thank you, everybody.
So now we are into the Q&A part of today's session. As a quick reminder, you can click on the little icon with the speech bubbles and question mark available on your dashboard. Click on that, which will open up the Q&A tool. You can start typing in your questions and we will get to them as they come through. Martina, I've got a quick question for you. How does the launch of BOA support the overall IBM strategies?
Thank you. While our solution is our solution, it is agnostic to the client's cluster configuration. So you can run your simulation anywhere. That simulation can be run in the cloud or on premises. It can be public, private, or hybrid cloud. It can be Power or x86, and still get the same advantage from IBM BOA.
Okay, I will just, while we're joined by Klaus, also from IBM. He's able to answer some of our technical questions. I think he's having some problems unmuting. So in the meantime, Glen, are you there?
I am indeed.
Okay, perfect. I've got a question for you. So obviously we've heard about BOA and how it's compatible with x86, power systems, an existing cloud on-premise and clusters. But what should people do if they're actually interested, but they want to get their hands on BOA to see how it's actually going to work in practice?
Yeah, thanks, Maz. So one of the key differentiators around the Boston Group is that we have a very large lab which is equipped with the latest equipment, and having one of the IBM appliances fits in with exactly how we like to deliver products to customers, giving them the ability to come in and test and validate the performance that it achieves. So we have it in our labs already. Anyone who is interested in test driving it, please feel free to get in contact with myself or the Boston Group, and we'll absolutely give you access to come and test it out. Thanks, Maz.
And just if it's someone's first time kind of using the Boston Labs, I know it's a very popular facility, but the first time that someone comes, is there an amount of hand-holding that goes on if customers require a bit of extra support getting to grips with things?
Yes, there is, especially on a product like this. There will be a bit of a learning curve, but once that's been overcome, it's a great product to use. So yes, we will very much hold the hand of anyone who comes to test the products with us.
Fantastic. I think, Klaus, you're now unmuted.
I hope so. Can you hear me now?
Yeah, we can hear you.
Oh, thank you.
So the question that we had come through for you was, how, if you have minimal data, can you make use of IBM BOA?
Yes, of course you can. That's to the heart of Bayesian optimization. You can use a minimum data in the beginning, and then BOA will give you the simulations to run next and guide you to update your minimal data for with the new data you're gaining from the simulations, and by that closing up to the optimal solution in there. So yes.
Okay, perfect. Thank you. Okay, so I think that is it. Thank you very much to Martina, Klaus, and Glen for your time today.
Thanks, Liz.
And thanks everyone for joining us for today's session. As a reminder, this is part of a series of webinars around supercomputing. You can find out more about what we've got coming up next on boston.co.uk. Thanks very much, and we hope that you'll join us again for another webinar in the future. Goodbye.